Hello and welcome, students and teachers, to another exciting session of Ideas at Neev, our first one this academic year. Our special guest today is Padma Shri, Padma Bhushan, MIT board member Kiran Mazumdar Shaw, founder, chairperson, and managing director of India's leading biotechnology enterprise, Biocon Limited. We are excited to have Kiran with us today. Kiran started Biocon in 1978 in a garage in Bengaluru with a seed capital of 10,000 rupees and calls herself an accidental entrepreneur. She faced a number of challenges while building Biocon, getting banks to fund her dreams and even recruiting people to work for a woman boss, facing challenges even in securing raw materials where suppliers did not want to deal with a woman. But she truly lives the message of being the change she seeks when she says, I believe in never giving up, no matter what the odds. My mantra is failure is temporary, giving up is permanent. She is today one of the most powerful and influential people in the world. With Time Magazine, with Forbes, with Fortune, many recognitions that recognize that. She also holds many key positions in various industry, educational, government, and professional bodies. And her entrepreneurial journey has changed the biotechnology industry in India and many things in Bangalore that we don't even know about. This morning, I opened the newspapers to find that she is continuing her civic quest by funding another metro in our city. Kiran is a thought leader and role model for entrepreneurs, leaders, researchers, women, and all citizens in India and, in fact, the world. Before we have her join us, I'd like to quickly make some housekeeping rules for the students and for teachers. Please address your questions in the Q&A box. If you raise your virtual hand, we wouldn't be able to attend to your question. Hence, we recommend that you use the Q&A box to share your thoughts and questions with us. And with that, I'd like to invite Kiran Mazumdar Shaw to join us. Thank you. Thank you, Kiran. Welcome.
Hi. Thank you, Kavita. That was over generous. I think you said too many kind things about me, but let me tell you that I'm absolutely delighted to be invited to, speak and talk about myself to the students, because I really believe that for a country like ours, our young students are our future. And I always make time for young students because they need to understand what life's journey is all about and why we need to have this eternal quest to do something that will make social impact. So I was one of those young, dreamy-eyed young students in school and in college where I said, now I must do something, I must pursue a career where I can actually be a part of the economic mainstream. I don't want to just sit at home. That was my ideas even when I was a young student. And then, of course, my late father was the one who really supported me in every sense of the word and encouraged me to pursue fermentation science in Australia. And in fact, when I first asked him why fermentation science, he said, look, because it can be applied to so many fields. And he was absolutely right. I had not thought about it that way. I learned fermentation science from a brewing point of view. But it was because my father opened my mind to saying how you should apply technology, how you should be agnostic to what you learn, because you can use it in so many different ways. That is what allowed me to become an entrepreneur when the doors of the brewing industry shut on me because I was a woman. They said, no, you are very qualified, you're very competent, but you're a woman and this is not a business or a job for a woman. So we cannot offer you a job. And that is what then, got me into an accidental, sort of situation with a biotech entrepreneur from Ireland who said, I want to start a joint venture in India. And I heard about you and I want you to join me in this partnership. And I immediately thought to myself, how can I run a company? How can I run a business? I don't even have any money. I don't even have any business experience. I don't even have any business qualification. And plus, I've just been told by many people in this country that women cannot be hired because they are not fit to do these kind of jobs. But nevertheless, something in me a rebellious streak in me said, let me show those people how I can run a business, how I can show them that women can do anything. And that's what got me into being an entrepreneur. And when I look back on it, I think it was a lot of foolish courage. And I feel foolish courage is very important because it motivates you. And that's what got me started in my garage. And you just mentioned I had only 10,000 rupees in the bank. But what excited me was about the thought of applying my knowledge, my fermentation science, to something which I had not thought about before. And that was in industrial biotechnology. So I started my journey in biotech as an industrial biotech company making enzymes. Nobody had heard of enzymes. Nobody was using enzymes in our country. And I thought I should make a change. I should get people to use enzymes, because the whole thought of using enzymes to replace polluting chemical processes was so exciting. And so again, I say to a lot of young people, entrepreneurship is about being driven by a sense of purpose. Why am I doing this? Something should be driving my zest and my zeal to keep doing it. Even though I fail and I make mistakes, I still pick myself up and carry on. Why? Because I'm committed to a sort of a general purpose. So when I started making enzymes, and these enzymes were I made it from 3 sources. One was papaya. The papaya fruit actually has an enzyme called papain. And I started extracting papain from papaya. And that was the big global opportunity for me. Then I started making fungal enzymes by growing certain very well-researched and sort of engineered fungi to produce certain enzymes. And that technology I developed in-house. It was a solid-state fermentation technology which produced a large number of enzymes for many, many types of industries. And then I had the yeast and bacterial fermentation, which was done in large tanks. And that was called submerged fermentation. So I did solid fermentation, submerged fermentation, and plant enzyme extraction. So I started developing these technologies, and we started becoming very, very successful in these enzymes. And in solid state fermentation enzymes, I must share with you that we were world leaders in solid state fermentation enzymes. And that is an area which made us extremely well known globally, because many of the enzymes that we were producing, we had monopolies and unique positions on those enzymes. Even though at that time, the amount of enzymes we were selling were not huge. It was about $5 or $10 million. But for that time, in the late 80s and 90s, that was a lot of money. Okay, so we were very happy because we almost had a kind of in some cases, 50% of world market share with those kind of enzymes, even though it was a small niche area. So that's what gave us the confidence that, we were doing something really exciting, something world-beating, and something which was something to be proud of, because we were doing it all in India. Our scientists were doing something very novel. Our engineers were designing plants to produce these enzymes in a very interesting way. Now, what happened was 20 years into that journey, we started looking at all these exciting technologies that we had built for enzymes. And I said to myself, as an entrepreneur, I want to keep reinventing myself. So I said, what else can we do with these technologies? So we looked at these. After all, biotechnology is just the harnessing of living systems to produce something of commercial importance. So whether it is an enzyme, or whether it is a biopharmaceutical, or whether it is a biofertilizer or a biopesticide, you can do so many things, okay? And today, with the convergence of digital technologies, data analytics, the whole focus has shifted to using these digital technologies in medical technologies for making devices, for making wearables, for doing research, for developing diagnostics, and so on and so forth. So I think the biotech sector is the most exciting sector, especially in today's context. But let me just now go back to how I got into biopharmaceuticals. So when I looked at all the technologies that we had developed, fungal technologies, bacterial technologies, yeast technologies, I said to myself, how can we also apply these technologies in some other field? And that other field happened to be biopharmaceuticals. And why biopharmaceuticals? Because there were certain opportunities I identified and said we must pursue these opportunities. The first opportunity was insulin. I found that India was at the epicenter of diabetes. We had a large number of patients for whom insulin is life-saving, and yet we were importing all our insulins from abroad. And worse still, there was a very new form of insulin called recombinant human insulin, which was actually mimicking the human insulin very, very identically. And yet, we were all using animal insulin mostly because we couldn't afford recombinant human insulin. Recombinant human insulin was being supplied in those days by two multinational companies, Novo and Eli Lilly. And they were selling recombinant human insulin at almost like 5 or 6 times the cost of animal insulin. So obviously most people would only then afford animal insulin. And as we all know today, animal insulin actually is very immunogenic because it is not natural to human beings. So when you use animal insulins, you get a lot of immunological problems. And so I said to myself, why don't I see whether I can develop recombinant human insulin in our country and make it affordable for these people? Today, you'll be happy to know that nobody uses animal insulin in our country. Everybody uses recombinant human insulin thanks to the efforts of companies like ours. And I want to take that credit because I think if we had not really looked at this opportunity and developed a recombinant human insulin using our own proprietary yeast technology that we had developed for certain enzymes, I don't think this would have happened. And today, Kavita, I'm very happy to tell you that Biocon is the only company in the world using this particular proprietary technology, which is our own yeast technology, which nobody else is using. And therefore, we believe we are the lowest cost producer of insulins in the world. Lilly uses a certain bacterial system, and Novo uses a different yeast system. And so we believe we have actually been able to compete with them because of our own efforts in developing a proprietary yeast technology. And today our insulins are approved by US FDA and European agencies. And of course, we sell it in India as well, but we sell it in 75 different countries as well, our insulins. And I just made an announcement last year at the UN, on the fringes of the UN General Assembly, that we as a company would give insulin at 10 cents a day to anyone who wants it in the world. And that's become a big pledge that we have taken. Now, this was an effort that, that we actually focused our whole purpose on in terms of providing affordable access to essential biologic medicines, which many of them are life-saving. And so we started with insulins, and today, as I mentioned, we've become very, very large in insulins. And then we followed it with cancer drugs, because cancer drugs, which were biologics, like, the breast cancer drug Herceptin or many other cancer drugs, which are monoclonal antibody based, these are very, very expensive drugs. And again, in India, I used to find that many breast cancer patients who needed that drug couldn't afford it. I mean, I had my own very dear friend who died of breast cancer, and she also had to use this drug. And even though she was a very well-paid employee, she found it very difficult to afford that therapy. And I said, I've got to change this. And again, I pursued our scientific efforts to develop this particular drug and many more monoclonal antibodies. Again, we are the lowest cost producer of these antibodies in the world. And we are approved in US, Europe, India also. We brought down the price 10 to 15 fold from what it was. And so therefore today, most people who need this drug can afford it. Governments can afford it also to give it free to poor patients, and so on and so forth. So the purpose that I'm driven by today is to make a difference to global healthcare by delivering affordable access to these life-saving essential medicines. So, as I said, when you embark on life's journey, you have to be driven by a sense of purpose. And there has to be a spirit of challenge, because nothing happens in an easy way. My life's journey, as you just mentioned, was full of challenges. Initially, nobody took me seriously. They said, what is this 25-year-old girl trying to start a biotech company? What is this biotechnology? Nobody has heard of it. God knows what she's trying to do. And then banks didn't want to lend to me. People didn't want to work for me. People didn't even want to do business with me because I was a woman. So you can imagine the huge gender bias that there was in those days. And I often joke that it was that gender bias that made me an entrepreneur, because I couldn't get a job in a brewery. So, but times have changed. Today, of course, nobody looks at me as just a woman entrepreneur. They look at me as a business leader. And because I'm doing something so different, because my business is so differentiated, I think people look at me very differently. And I want to tell young women on this particular show that, look, believe in yourself, believe in your strengths and your capabilities, and be a lifelong learner. You must keep learning. You must keep understanding that building credibility is a very, very important mission in life. It's not just about women who need to build credibility, but anybody and everybody needs to build credibility. If you're a scientist, you have to build credibility by publishing, by doing good research. If you're a writer, you have to earn credibility by writing well, by making sure that your writing is carried in very well acknowledged publications. And the same goes for any profession. Building credibility is about earning that respect. And that is what life has taught me, that life is not easy, but as you overcome obstacles, as you overcome failures, as you reach success, you start building credibility step by step. And it is that credibility that then earns you the kind of recognition that I have fortunately earned through many, many awards and national awards and things like that. But it happens not just because I know people or I'm connected. Actually, that's one thing I'm proud of. I haven't got any of these recognitions and awards because I've used influence. It's because of doing something with a sense of purpose. It is doing something which people have noticed because it's important for society. So I think that's what I want to tell young people, that it's not about the money. It's not about I in fact, I'm very often, I get very embarrassed when I'm called the richest woman, self-made woman in India. But to me, it's an important recognition, because it's not about the money, it's about the value I have created. You see, it is the wealth I've created for all the people who have worked for me. And it is a recognition that what we have done is so valuable. That to me is important. It's not important that I'm in the Forbes rich list or whatever it is. I don't want to be known for that. I want to be known for having built a big biotech company in India, a world-class global biotech company in India. I want to be known for the kind of products we developed and made a difference to patients across the world. And I want to be known for my philanthropy. So that is what, in a nutshell, was my life's journey. But now let's come to the importance of biotechnology in today's day and age. What has happened? COVID has suddenly brought a huge focus on the importance of life sciences, the importance of healthcare, and the importance of biotechnology. So let me tell you how. So first and foremost, if you look at what are we all waiting for? We are waiting for a vaccine. Okay. We know that biotechnology has been one of the biggest contributors to human health because of vaccines. And these vaccines are extremely important to make sure that it immunizes the world populations against these kind of viruses like coronavirus 19, COVID-19. Now, what I'm saying is that these vaccines are made in very different ways. But understanding how you develop vaccines is all about biotechnology. How do you basically culture these vaccines that you're developing? So what is a vaccine? A vaccine basically is about taking a very mild form of the virus in any way that you can. In this case, they've used the spike protein of the virus, which is what really causes all the problems, because that's the protein that gets into our bodies and causes all the immunogenic responses and starts creating all the havoc that we've seen. So they've taken the spike protein, camouflaged it in a mild, viral vector, as we call it, like the adenovirus, which is found in our bodies quite regularly, and then giving people that low dose of that same virus, but in the form of the spike protein, and hoping that the body will then, react to that and build up all the immune responses in terms of T cells and antibodies to protect us. So in a nutshell, that's what vaccines do. But then you have to produce these proteins, this spike protein. You have to produce it and produce it in an adenovirus vector. Then there is the mRNA vaccine, which also uses a similar concept, except that it actually creates the mRNA that codes for the spike protein. And then that's what you put into human beings. So, but all these require technologies, and these technologies are only possible because of biotech. So you produce them in bioreactors, and then you basically then have to go through a purification step. You have to go through a fill and finish step, and that's how vaccines are produced. But now you must have also heard about the antibody cocktails that are also being used to kill the virus. Now that also is a biotechnology, because you have to produce these antibodies. We do it at ton scales in our company. And therefore you need to produce these at great scale, because they are going to be using these antibodies not just to treat patients, but they're even thinking that these antibodies can be used for treating elderly patients who may not have the immune response to the vaccine. So you can see how we are using science, how we are using biological sciences to understand these viral diseases, these infectious diseases, and then develop products that can actually help us cope with these diseases. Similarly, when you look at why is biotech so important? Because all this time, the pharmaceutical industry used to make chemically derived drugs. These chemically derived drugs actually are very good at replenishing or doing things which the body does chemically. So if there's a deficiency of a certain chemical, if you give a chemical, it actually solves the problem. Many chemicals are also used to stimulate certain pathways. So those kind of drugs are also good. But remember, our body has got a lot of biological activity. So if there's a deficiency or an over surge of a biological activity, how are you going to deal with it? That is the question. Insulin today is actually a hormone that is produced by your body to metabolize glucose, right? Now, when your body, and this hormone is produced in your pancreas, and this is the insulin is what allows you to do glucose metabolism in a very balanced, effective way. When there's a deficiency of insulin, then you get diabetes. Now, how do you deal with diabetes? There are many ways of dealing with diabetes. One is you use chemicals that will stimulate the production of insulin, but you know that you can keep stimulating the production, but there will come a time when that stimulation will not have the kind of impact that it had initially. So what is the best answer to insulin is insulin itself. So how do you make insulin? And that's what I talked about. There is a gene that codes for insulin in your body. So if you know what that gene is, you can actually plug that gene into a microbe and get the microbe to produce that insulin. And that's what we do. That's biotechnology. Mimicking what biological systems do and doing it in a way where you engineer microbial systems to do that, because you can produce it at large scale. Okay, so I think that tells you what biotech is about. And similarly, if you look at it, antibodies, now we know that cancer is a disease that happens because your immune system goes wrong. Your immune system is supposed to take care of cell cycle replication and death. And very often your immune system does not complete the cycle. And instead of the cell dying, it keeps on replicating. So now something has gone wrong in your immune system. All this time we used to keep using chemotherapy to kill those cells that were going out of control. But it kept on appearing somewhere else, right? Today we find that if you know what is that immune signal that has gone wrong, and if you can correct that immune signal, you can kill those same cells without having to go through all that toxicity that you get in chemotherapy. So I think that is the power of understanding biology, immunology, and developing products that can actually do that, which is mimicking how your own body deals with these kind of situations. Let me tell you, the human body is the most amazing, complex computer that one can ever imagine. The way it manages networks, the way it signals networks, the way it stops and starts things, I don't think any computer in the world can do that. Your human body is the most powerful engine, the most powerful computer, and the most rapid data analytics and you're talking about AI. Think of what your human body is doing every single nanosecond. It is looking at data and analyzing it at the kind of speed that no AI computer can ever do. That's the power of it. We are faster than quantum computers. So once you understand how the human body deals with disease, deals with health, deals with anything, then you can develop products that can either correct the deficiencies or correct the augmentation of certain processes that shouldn't happen. So this is the power of biotech. Similarly, you can see that biotech is being used in dealing with the environment. Today, COVID has shown you that, the environment can be rescued. And the environment was rescued simply because we suddenly brought a whole amount of human activity to a standstill. And suddenly our water bodies were cleaned up because there was no industrial effluent going into those water bodies. We suddenly found the air is seeming to be much purer because there's not all this vehicular emissions going into the atmosphere, and so on and so forth. And today we are recognizing the fact that we should see how we can sustain this clean environment. And again, I can tell you that biotech has a big role to play. So, whether it is the bioremediation that we can do in all our polluted lands and water bodies, or whether it is actually biofuels that we can produce. Of course, electric vehicles are also very important. So I think biotech has a huge role to play in this. And then when you look at agricultural technologies, of course, everyone thinks about genetically modified crops, but I would actually like to point you into a different direction. We know that certain genes are very important for improving productivity. There are certain genes that allow, crops to basically withstand drought. And there are certain genes which allow plants to actually withstand a lot of flooding. So if you were to look at those genes and augment them, that is, replicate those genes, or insert such genes in plants so that they become better from the same species, I think you can see how you can improve agricultural productivity. And so it's not about, people always think about Frankenstein genetic engineering, but it's not that. It's about making sure that you understand what genes do. It's like us, where we have taken the human gene to code for insulin in an organism. The moment you understand what genes do and you can do it safely, then that's the power of technology. So I don't think we should start getting worried that, oh God, what is a genetically modified crop? One starts imagining that you've taken one some animal gene, and and you've done something, and the crop is producing something completely different. That's not what genetic modification is. In fact, I don't even like to call it genetic modification. I think we should call it genetic enhancement, genetic augmentation, because these are some of the things that we can do. If you keep replicating one gene in a plant, which is very good for productivity 2-3 times, if you give more copies of that gene, you will suddenly get higher productivity. That doesn't alter the crop itself, but it just gives you more productive, the productivity of that plant goes up. So I think we must look at technology in a very scientific way. And of course, we must look at it as safe science. And I can tell you that biotech is regulated with a number of requirements that makes it a very, very safe science. So any one of you who's very interested in biotechnology, I would urge you to go for it, because this is one of the most exciting opportunities that I have seen in my lifetime. I'm so glad that I studied biotechnology. I'm so glad that I'm actually in this business of biotechnology, because it gives me a tremendous amount of fulfillment and satisfaction that I'm making a huge difference to mankind. So I think we are in a humanitarian business making biopharmaceuticals, but it gives me a lot of satisfaction that we are able to give many of these life-saving essential medications to patients across the world at a price point which they can afford because of what we've done with technology. So maybe I should end there, Kavita, and take up questions.
Thank you. Thanks for sharing that, Kiran. That was incredible. And I think we as a world, we've just come such a long way in even in vaccines, from that first vaccine, I think, which was probably the smallpox vaccine, where the scabs the scabs would be dried, and then very small amounts of that would be pinpricked into the human body. So to come from that to where we are today is just incredible. And a lot of our students are interested in the biological sciences and bioengineering, but they haven't really considered the sort of sciences that come together. So when you're talking about when you're talking about the original work that you yourself did, it was sort of bio and chemistry coming together at one point. And then now with the work that's happening with drug delivery systems and insulin, and the kind of work, kind of delivery systems, and the kind of...
And the diagnostics.
Right.
If you look at how diagnostics are developed today, so you understand, I mean, let's take, for instance, the RT-PCR test for COVID. So what are you doing? You're taking a nasal swab, you're getting small amounts of the viral RNA. Then to detect whether the RNA is not, what do you do? So you put it into a system which is called a PCR machine. And the PCR machine amplifies the RNA as many times, so that if it is there, you can detect it. And then that's what you report as a positive test.
Right.
And now if you look at insulin, look at the way you are measuring insulin today. Previously it was always taking a pinprick and taking the blood, then seeing whether what is your glucose level. Today you can have a patch on your body, and it's got fine needles, so it sits on your body, and it's constantly monitoring your glucose level in your blood and giving those signals to your phone. Look at how advanced technology is. So you're combining these information technology, biotech, and all this kind of other technologies. There is a huge convergence taking place.
Yes. I mean, data science as well, right? So you're bringing together data, you're bringing together humanities, because of, all of the sciences coming together, right? So it's no longer biology and chemistry anymore. It's all...
No, and it's real-time processing, because remember, our own body processes so much data all the time. So we are actually mimicking the body's data analytics, because our body keeps on processing data and responding to that data real time. And that's what we need to try and do.
Right. And all of that is taking us to this space of from going from therapeutic to preventive care, right? Including the work which is on the microflora of your own body, knowing that through data.
Microbiome, yes.
It's incredible, the kind of work, from wearable technology to all of that. And that's what we always tell our students, that biotechnology is not about being only interested in biology anymore, or the field of health is no longer about, it is about economics, it is about biology, it's about physics, chemistry, it's about psychology. It's all of those lines really coming together and working, because it's only when they come together is when you will see that sort of work. Now, when you're looking at even with COVID or for anything else that we're reading, because we're reading so much of health and treatment stuff in the last few months, you see all of these fields abroad, whether it's in hospitals or with companies. All of these fields seem to come together all the time. Engineering and data and just all of that. Besides the biological sciences, obviously, how are we doing in India, Kiran, on that? Is that true in India as well?
So unfortunately, Kavita, our whole education system has been in silos. We tend to compartmentalize our education and knowledge. Like what you just said.
Yeah.
Biology is biology. Data science is data science. Engineering is engineering. But in the last 10 years, I would say that a lot of good things have happened. So we are recognizing that bioengineering is extremely important, and we are also seeing that data science has to be embedded in the way we teach biology. It is going to take some time, but I think many of our new universities, even when you go and do a biotech program at IIT, they are focusing a lot on the convergence of these technologies. So I think it is extremely important. I serve on the board of MIT, and I know how much we emphasize multidisciplinary approach to teaching and understanding and researching. And every research institute, research center at MIT is about the convergence of different technologies, people from different domains coming together on a research project.
Right.
And that's what is so important.
Right.
That just like you said, you have to open your mind. You may be interested in one aspect. Yes. That's fine. But collaborate with someone else who comes from a different side. Don't just insulate yourself with only, people who are very homogenous. And that's the mistake we tend to make in India. Yes. We always stick with one type of capabilities or one type of thinking, and then you have blinkers.
Yes. Yes.
Today, if you look at it, immunology, which is such a huge field, we should be actually masters in that because of the kind of diseases we have in this country. But unfortunately, our immunological sciences don't have the kind of visibility and focus that it should have. Why is it that a country that has so much, focus on TB and infectious diseases doesn't have that many publications in immunological sciences? Or, why is it that our vaccine research is not as high as other parts of the world? Why is it that our understanding of virology or viruses is not as high as other parts of the world? And yet we should have it, because many of our Indian origin scientists are the ones who are leading the way in many other parts of the world.
Yes, absolutely. I think it's so the question is that what is the solution for this? And with the new education policy, the national education policy also emphasizes this multidisciplinary learning. But we know this is hard. We know that our teachers are not set for this. We know that our school curricula and our assessment are not really built for this. Do you see that as a country, in how much time realistically do you see a change happening? Or why realistically? Why realistically? Why not ambitiously? How much of...
I would say we have to be a bit realistic. When you start from a kind of a disadvantage where you've done things in a very different way, and now you want to undergo transformational change, you have to give it a bit of time. So I don't think you're going to see real perceptible change for 10 years. You have to keep doing it. For 10 years, you have to break down the barriers. You have to break all these boundaries you've created, right? So it takes time.
Yeah.
When first you'll blur the boundaries, then you have to break the boundaries, and then you have to make people work together. All this is going to take time. But I think what you need to do, with some of the good things that they've done is to get into project-based education, which is also important. But we must choose projects that force you to be multidisciplinary, where it will bring people from different walks to solving that project. And more than anything else, Kavita, we have to encourage problem solving. Don't give them the answers. In my own company, people tell me, what is your management style? And I always say my management style is, I want people to solve problems. I don't want people to carry out tasks. I am not a taskmaster. I always tell people, here's your problem, go and solve it. Let me see how good you are. And when people solve problems, they themselves become very energized and very emboldened, and they get this sense of self-confidence that I solved this problem. But if you tell them, oh, by the way, I want you to do this, and I want you to do it like this is what we all do. Even in our education, what do we do? Right. Here's the textbook, here's the chapter, please learn it, and tomorrow I'll ask you questions on this. That's not the way to teach.
Memorization.
The way to teach is, look, learn about this, and after you learn about it, you ask me questions.
Yes.
Which you want to know answers to. Yes. And I will ask you questions beyond what you just learned, and let me see if you can find those answers.
Yes. But there's a lot more that our students can do even before all of this happens, before this change happens, because through being open to recognizing that scores are not everything. Scores will get you to the right college possibly, but they're not going to get you beyond that. So
Kavita, I'll share I'll share an example of my own college days. I'm talking about in the 70s, okay? Right. You can imagine those were not the times of today, right? But we used to have wonderful teachers, okay? So there were teachers who would tell us, and I remember this very vividly, we had a fantastic teacher who taught us embryology in my zoology BSc. And he said to me, he said, okay, I'm going to select 10 of you. And 10 of you, I'm going to give you one embryology lesson to teach to the rest of your class. And I'm going to basically recognize the best classes. So he used to actually challenge us with learning the subject ourselves and teaching it to everyone else. So that was a fantastic way for us to understand the subject and get others to understand the subject with us. So, there are various different experimental ways of teaching and education. Right. So it's not about the teacher coming and giving some blackboard examples of, oh, this is how this chick embryology is, and this is how it is done, and this is how the embryo develops. That was not it. He said, I want you to understand it, and I want you to understand it and draw the things on the board and teach it to your children. Those days we never had computers, by the way.
That's amazing. So I think that at that time is incredible. Today, as an IB school, we call that flipped classrooms, where children are given tasks and they have to come back in and.
But I'm talking about the good old days.
That's amazing.
And then we used to have all these practical classes where they used to give us very little marks, which I thought was wrong. Because, you should balance practicals with theory, and you can make the practicals much more interesting. So I remember we used to again have wonderful teachers. It's all about your teachers, how they arouse your curiosity, even when they're teaching you something.
I'm going to move to some of the student questions because we otherwise don't have any time for that at all. So there is Meher who's asking an interesting question. In one of your articles, you said that businesses must look at the SDGs more earnestly. Post-COVID, which SDG should we be looking at, prioritizing and working towards first?
So I think obviously there are many SDGs that you have to look at. Of course, one is our whole healthcare system is broken. And that we have to look at fixing this healthcare system is a very important SDG. I just mentioned about environmental sustainability because that's something which has come to our attention during this time, and we must see how we can protect our environment because it's extremely important. I think, of course, the whole issue of equity economic equity, gender equity, all that has come to the fore, because you've seen that when we had the migrant labor, when we had, the job losses, when we've seen even jobs coming back, women are not getting those jobs. It's the men who are getting those jobs, right? So, and then when we are looking at rural, the disconnect between rural and urban economies, it's so glaring. Now we are seeing that agriculture is also becoming a very important part of our economy. So I think there are so many goals in the SDGs that we can actually focus on. But to me, I think health, education, and the diversity, aspects are very, very important for us to look at.
Thanks for sharing that. Vineet Singh, a teacher, is asking, what is the role of ethics in the field of biotechnology? So I'll extend that a bit to say that, what are the current ethical issues related to biotechnology that we are facing in India, and are they different from the ones that are being faced globally?
So I think every scientific field will have ethical issues, because it's about the use and abuse of that technology. Today, nuclear technologies can be extremely unethical if you use it for the wrong reasons. So anything and everything that you use for the wrong reasons is unethical. I believe that ethics lies with us. And I think the ethical question is, are you using a technology for societal benefit? Are you using technology to improve the lives of people? Are you using technology that will actually help human health, human activity, human life? These are the questions which become ethical and will drive you and drive your conscience to taking the right decisions. Anything can become unethical if you're doing it for the wrong reasons. And therefore, I believe that's the ethical debate we ought to have.
Right. Yes. So student Aryan R is asking about the CRISPR-Cas9 gene editing and its potential. I know that you've written on this as well, Kiran, and especially with the new Nobel laureates.
Yeah.
Yes, both the ladies. And so could you give us some insight into that? What is the potential of this technology? Do you see this as being something huge in healthcare and in...
Well, I think, this is a tremendous technology. I think CRISPR-Cas9 is a wonderful gene editing technology, which allows you to look at any gene and modify it using these so-called genetic scissors to really edit them into a form and, to do something which you want it to do. I mean, if you can use CRISPR-Cas9 for many things. You can actually edit out unhealthy genes. That's also very important, because very often a misspelled gene can actually give you a lot of genetic diseases, genetically inherited diseases. So if you've got misspelled genes, you can edit them into the correct spelt genes. And then when you bring it back into gene therapy and bring it back into the human body to correct that genetic aberration or that misspelling, you can actually save lives, right? You know how many of these genetically inherited diseases are life-threatening. There are many diseases where people don't even survive beyond the age of 5. And so on and so forth. So there are many of these CRISPR-Cas9 technologies today that are being developed today. Of course, so far we haven't really seen CRISPR-Cas9 therapies being approved as yet, but it is already in the clinic. So you are seeing many of these technologies being developed using this gene editing technologies, which also can be used in plants and can be used in any living system. But you've got to know what you want to do with it. And again, it comes back to the ethics of it. So if you're doing it for the right reasons, you will definitely come up with some amazing solutions and therapies. And that's what we need to look at CRISPR-Cas9. Today, of course, we've also looked at CRISPR-Cas9 technologies to develop, as you know, diagnostics, right? So those are the kind of things you can do with these kind of technologies, which are really sort of far-sighted and world-leading, world-beating technologies.
What is your view, Kiran, on the Feluda test? The Feluda test, which kind of goes after the Sherlock technology from the US, right? So, what's your view on that Feluda
So
test?
I think the only thing about that test is that it is a qualitative test. It's not a quantitative test. So when you want to do these kind of tests, you like RT-PCR is both qualitative and quantitative. So the Feluda test is a qualitative test which will say yes or no, but it doesn't tell you what the viral load is.
Right, right. But they talk about a very high degree of sensitivity and specificity, much more than even, is that
No,
adequately?
but you must understand what is sensitivity and specificity. So when you talk about specificity, it's about how specific the particular diagnostic is to that particular virus, say for instance in this case. So that is a very important thing to have. And sensitivity is that does it pick it up at a very low level,
Yeah,
right? So that's also very good. So you are getting that readout.
right,
But very often you also want to have a quantitative readout.
right,
So
right.
do you have a high viral load or a low viral load? So it just comes out positive. It doesn't tell you whether it is high or low.
Yeah, yeah,
Right?
yeah, yeah. So, Mahi Noor wants to know, Biocon has been working on oral insulin. How does it work and how successful have you been with this?
Well, I think we've had some really, really good, indications of oral insulin, and we've seen some really good data coming out. Because of COVID, of course, some of our trials have got a little affected, especially some of the trials we are doing in type 1 diabetes overseas. So some of these trials have got delayed, but nevertheless, we are plugging on. I think my biggest concern is, as a country, are we ready to embrace new technologies? I think that is a big question I have in this country, that we always look to the West for new technologies and new products and new innovations. And therefore, I've got a little disillusioned about our belief in research and innovation. We talk about it, but we don't deliver on it. We don't deliver on the promise. And these days, it's very sad to see that many innovative companies are actually taking their research outside the country because they feel that we don't have enough respect for our own innovation. I can tell you that I have done a lot of innovation in this country, including my insulins for that matter. I sell more insulin outside India than I sell in India. Okay, so that's because our medical professionals simply believe that anything coming from outside is more reliable than what is available in our country. So I think we have to change that narrative. If we start changing that narrative and we start changing the belief that our innovation is very good, then you will have a huge mushrooming of innovation, and you will have a very different ecosystem with lots of people wanting to invest in our country. Because that's a big challenge we have. There are so many young startups who get stunted because people don't invest in them to take them to the next level. And the reason is we really don't have a good understanding of what innovation means.
Right, right. Even today, you think it's
Even today.
So are these challenges? Aryan R has asked so many questions, so I must plug in one of his questions for sure. Here we have a few more minutes for a couple of questions. India has been seen to lose a lot of great talent in the entrepreneurial space and to other countries, and because India lacks something. Being an entrepreneur yourself, what were the things that you felt India lacked in terms of resources, mindset, and other aspects compared to other countries? And how do you think India can improve on those aspects in order to avoid losing this talent to other countries? Yeah, I'll stop there.
So I'm just saying there's no lack of resources. I think resources are there, but it's the mindset that has to change. I'm just giving a simple example. Until March 31st this year, every company who invested in research and development could get a tax incentive for investing in research and investment. They have removed that incentive, which means that they don't think R&D is so important for industry, right? They say, no, you guys are making a lot of money. You should actually find your own money to do R&D. Now, all these, that tells you what the mindset is. The mindset is that no R&D, and remember, R&D is an expense as far as the financial reporting goes. So you're caught in a double-edged situation, because if you don't invest in R&D, it's not good for your business. And if you invest in R&D, it's not being incentivized. So what do? So you under-invest in R&D. Instead of encouraging people to invest more in R&D, you're telling them don't invest that much in R&D. So I just feel that the mindset needs to change. You know, the people who are the policy makers need to change their orientation on R&D, and especially at a time of COVID, when we need to invest so much more in R&D, where you have seen at last our national laboratories are beginning to innovate. Our national laboratories are beginning to unleash their innovation potential. I think this is also a time for private sector to do the same. And there's another big problem in our country which we need to bridge. It is the trust deficit between the public and private sectors. Today, the private sector, doesn't reach out to the public sector that much. And public sector doesn't trust the private sector. So if that is the kind of mindset we have, we are not going to take advantage of all the potential we have.
Is the government listening to you at this point, Kiran, with government of Karnataka? Are they listening to you on the kind of stuff? Today I was looking at the headline which says antigen. The health minister or chief minister has said lesser antigen testing, but more RT-PCR. And I was just thinking, that wow, that's a little bit off. So I think it's.
No, it's not off. It's actually correct. If you do RT-PCR testing in a pool testing way, it is far more reliable than rapid antigen testing.
Yes, of course.
Because we know that rapid antigen testing is not only sensitivity levels are not that high.
Yes.
So it's good for a rapid readout.
Right.
But if you really want a much more accurate readout, you don't have any option but to do RT-PCR. Right. But you should do it through pool testing. But which ramps up your capacity 5 times.
Is the government listening to you and people like you?
Well, I think they've got a good group of people thinking about it, and that we are working with them to discuss these kind of things.
That is.
But I would say Karnataka actually listens to the private sector, works with the private sector, and partners with the private sector, unlike the rest of the country. Maybe right. Some states are still an exception, but by and large, I think today the public sector believes we know what we want, we know what we are doing, we don't need the private sector. And private sector is saying we don't need the public sector because what are they doing? So that is a bad trust deficit that we have created, which must be bridged.
That is wonderful.
And Karnataka has it. That's why we have the best incubators, accelerators, and companies in Karnataka in the tech sector. Why do you think CCAMP, which is a public sector incubator, has all the private sector startups in it? That's a great example of public-private partnership. And that's because, Karnataka has this interesting model where I chair the vision group on biotechnology. Chris Gopalakrishnan chairs the IT vision group. So I think because they are working so closely with us, the bureaucracy also is in sync with this private-public partnership model.
Right.
I mean, you can see even in the metros, all of us are building metros for the government because there is a good trust between public and private.
Yes. So, I think we've run out of time, but I just want to ask you this one last question. Suhani is asking that how can we as school children, she's in grade 9, she's asking how can we as school children involve ourselves in some research and development? Any thoughts, quick tips?
So I think it's very important for schools to start partnering with research centers. Like we have so many national and private research centers, and we ought to get them to give us few projects for children to participate in.
Right.
So I think learning science is very important. We are creating what is called as the Science Gallery Bengaluru.
Yes.
Which is going to be a fascinating place for young people and citizens to understand science and get engaged with science. I think every city ought to have that kind of approach. So I'm very happy that because of the foresightedness of the government of Karnataka, we're bringing all this for the students. You know, we have something called Science Habba, where we're getting all the schools involved in, you know, science projects and blah, blah. So you've got to get that excitement and buzz about science.
Yes. Yes, yes. So I think, you know, Kiran, I just want to close with this thought for you and also let you comment on it, that with everything that I hear you saying, and I've heard others saying, I've heard my own father saying, that patriotism is a big part of entrepreneurship when you take it up in India. And is that different from anywhere else in the world? Is this, you know, I mean, you're talking about not just your involvement with biotechnology and with the government, and but also with the civic work you're doing, and now also with the science gallery, the fact that you chair that group as well. I mean, it's incredible, right? So you're creating change for the country in many spaces besides just for your own company. So patriotism in that sense seems to be a key part of really big entrepreneurship in India.
You know, I may not completely agree with you there, Kavita, because if you look at great entrepreneurs anywhere in the world, it is about their immediate communities for sure, you know. Yeah. But what I'm saying is that, yes, for many of us who have, you know, who belong to this country, obviously that adds a little more. But remember, there are so many great, entrepreneurs who've gone from other countries to other parts of the world and become big success stories. So who are, you know, what patriotism are you talking about? Are they patriotic to their original countries or to the new country? So I don't think patriotism in that sense, is so important, as you're belonging to where you are based.
Create value where you are.
So you've seen Elon Musk is from South Africa.
Yes.
But he's been a big resounding success in the US, right? And there are many such examples of entrepreneurs who come from other parts of the world because their opportunities were not great there. And they've come to other parts of the world and become hugely successful. So if you ask about patriotism, then who are they patriotic to? They are patriotic to both, you know, the new country and the old ones from where they came. But what makes them very successful is that they have a sense of belonging in the communities in which they are pursuing their entrepreneurial journeys. So for me, of course, it's very different because I'm born in Bangalore. I'm very proud of Bangalore. I'm very proud of, doing something for my country. Sure, I think that's very important. Yeah. But I think you must, for me, what is even more important is that sense of purpose. Why are you doing it? What is it that drives you? See, nationalism is something that you can fall back on. But what drives you? Driving me is not nationalism. Driving me is that sense of purpose, that I can make this huge impact on healthcare, starting with my own country, of course.
Right. So thank you so much, Kiran, for doing this. And we've run over time. Kids, I'm sorry we can't deal with the rest of the questions. But on behalf of Kiran, I'm going to tell you, keep thinking about this. Go out, read more, read one solid science article today, pick up a book, and just let's get this going. Let's recognize that creativity lies at the intersection of all of the disciplines that you guys are studying.
Not science and technology is cool. That's what you should remember.
It's certainly cool. Absolutely. So thank you so much, Kiran, for taking the time to speak with us. I'm sure the kids would have, the questions are still continuing. Guys, we will stop. So we'll stop there. And so thank you so much, Kiran, for taking the time doing this in your busy schedule. It's very impressive that you agreed to speak with us.
Thank you.
So we hope we will have a bunch of students that will be change makers.